Hey guys, we're going to do section 11.2 here, which is on arithmetic sequences. So first we need to start off with a definition. An arithmetic sequence is one where each successive term has a common difference. Another way of saying that is these sequences always go up or down by a fixed amount with each successive term. So perhaps your sequence is 2, 4, 6, 8, 10. So you can see that you're going up by 2 every time, or maybe it's I don't know, let's say 18, 15, 12, 9. So we're going down by 3 every time. But arithmetic sequences are always based on that concept. They're going up or down by the same amount with each term. So A1, there's little subscripts here. The A1 will always be the first term. AN is just the nth term, whatever, might be the 5th term, might be the 20th term. It's just some undefined n when we're using it as a general formula. And then D is what we call that common difference. It's how much it's going up or down with each term. So first thing we need to be able to do is identify if a sequence is arithmetic. So looking at this first one, we see that we would add 1 to go from 1 to 2, but we'd have to add 2 to go from 2 to 4, and then we'd have to add 4. So the thing that we're adding each time is different. So this is not an arithmetic sequence. All right, for the second sequence, -3, 1, 5, 9, looks like we'd add 4 to go from -3 to 1. And if we add another 4, we get 5. If we add another 4, we get 9, etc. So each time it looks like we're adding 4. So this would be a yes, this is arithmetic, and the common difference is 4. All right, so here's an example. I thought about doing this on the document camera, but I just decided to animate the solution here in the slide, so hopefully this works for you guys. We have that the 5th term of an arithmetic sequence is 20, and the 14th term is 65, and we want to write out the formula for the nth term. So we're going to start out with 2 simultaneous equations. Okay, we're going to say the 5th term here, just using the nth term formula, the generic formula that I gave you on the very first slide, we know that 20 is the 5th term in the sequence. So we don't know the first term yet. We don't know D yet, the common difference. But we do know this information. And likewise, for 65, we know that it's the 14th term. So we can plug these pieces in, and then we can simplify both of these equations. So 20 is the first term plus 4D. 65 is the first term plus 13D. Now what I'm going to do is, because I'd like to get one of these 2 missing variables out of these equations, I'm going to subtract these 2 equations. So 65 minus 20 will give me 45. Notice that A1 minus A1 will go away. And 13D minus 4D is 9D. So we have 45 equals 9D, which tells us, of course, that D is 5. All right, now I'm going to use that information and I could pick either one of these, but I'm going to use this one, the 20 equals A1 plus 4D. And I'm going to go ahead and plug D in now that we know it. Okay, so 20 is the first term plus 20. 4 times 5 is 20. So therefore, A1 must be 0. So our formula for the nth term, putting these pieces together, is the nth term is 0 plus n minus 1 times 5. So in the end, you don't really need to write the 0. But in the end, your nth term formula, the only variable in it should be n. So that if someone just asked you, what's the 7th term? You could plug in 7 and get the answer for the 7th term. Or what's the 100th term? And you can plug in 100. So again, the 0 is not necessary, but I wrote it just to kind of make it fit the pattern for the nth terms formula. All right, we talked about recursive formulas in section 1, so that's coming back here. With arithmetic sequences, the recursive formulas are always the same. Okay, every single time. It's A sub n is A sub n minus 1 plus D, the common difference. And that applies for n greater than or equal to 2. Remember that the first term, when n is 1, that has to be given to you. Or, in the case of this example, you have to supply it. Okay, I'm going to give you this sequence. -18, -7, 4, 15, 26. And we want to write a recursive formula for this sequence. Well, remember, the first term always has to be given. So the first term is -18, as we can see just from the list. But then after that, it looks like we are adding 11. Negative 18 plus 11 would be negative 7. Negative 7 plus 11 would be 4. So our common difference is 11. So the formula for the recursive formula for the nth term is just going to be a sub n minus 1 plus 11. So recursive formulas are pretty easy if you know that the sequence is arithmetic. All right, one more application here of arithmetic sequences. In this case, we want to find the number of terms that are in this arithmetic sequence. It goes from 8 to negative 41. We don't know, we see the ellipses there indicate we don't know how many terms there are between negative 6 and negative 41, but we should have enough information to be able to figure it out. Our first term is 8, and we can figure out that our common difference is negative 7, right? This sequence is going down by 7 every term. So starting with our basic nth term formula, we'll plug in the pieces that we know. Negative 41 is the last term, the nth term. A sub 1 is the first term, that's 8, and then D, our common difference, is negative 7. So all we have now in the equation, or the only variable we have in the equation, is n. So we can simplify a little bit. I just distributed the negative 7 right there. And then we can combine all the constants and get them over on the left-hand side. So we get negative 56 equals negative 7n. So n must be 8. So therefore there are 8 terms in this finite sequence. All right, so I think that covers all the skills that you need in order to work on the homework for 11.2. We probably could have squeezed 2 sections in here, but I wanted to end in just the right place this semester, so I think this is the way we're going to do it. And so your homework for this section is here, numbers 11 through 19 odd, and then I hand-picked a few after that I thought would be good practice. So good luck on this. My plan is to have a quiz on Thursday. On Thursday. So let me know if you have any questions about this via email, and otherwise, good luck.